In the previous section, we looked at the definite integral, which gave us the area underneath a graph, but it was bounded by the x-axis and two vertical lines, A and B. And so we integrated between A and B f of x, and that gave us the area of this region. What we're going to do in this section is we're going to take two functions. We're going to take an upper function, we'll call that f of x, and a lower function, g of x, and we're going to find the area between those two curves. Now the way we're going to do that is we're going to go back to what we did here, and we're going to find the area that's bounded below f of x, which would be all of this, and then we would find the area bounded below g of x, and then we would subtract them. So what happens is we're going to have this integral, again from a to b, because we're still bounded by the two vertical lines, but we're going to take the area that's below f of x and subtract the area below g of x, and that's going to take the area between those two regions. Let's look at another just picture. All right, so as we have this picture, we have this parabola, and we could call that g of x. But what would be our upper function? Well, it would be the x-axis, which would be f of x, which of course would equal to 0. And so we could set this integral up. All right, our boundaries would be from -1 to +4. F of x, which would be 0, minus g of x. And that would give us the area bounded between the upper function f of x and the lower function g of x. Let's look at this next picture. It looks kind of scary. So we want to find this area right here. So above the upper function, if we call that f of x, that looks like some line. And then the lower function right here, let's say g of x, is some parabola or quadratic function. And then we would have the boundaries between 1 and 2. So our integral would be between 1 and 2. F of x, which is the line, minus g of x, and that would give us the area of that shaded region. This is the same situation. We have a line and a parabola. The line is on top, the parabola is on the bottom, but this time we would have to figure out where these two curves intersected, and so they've given us these values, and we want to use the x values. So we would go from -1 to 3 of f of x minus g of x, assuming that the line is f of x and the parabola is g of x. Alright, so let's look at this last example. So we have this function, let's call it f of x, and this is the curve, and then we have this line, let's call that g of x. So you will notice that sometimes f of x is above the line, but other times it's below the line. So in order to find the area, we have to be very careful. We have to kind of stop at the points of when it's above and when it's below. So if we go from, we integrate from when x is -2 to x is 0, and we take f of x minus g of x, that would give us the area for region 1. But then as we went from 0 to 2, we would have to do g of x minus f of x to give us region 2, and then to find the total area, we would add that together. So a picture really helps to let you see what function is above the other one so you know which order to subtract. So let's dive in and find the area of the shaded region. Now notice that we have the curve x cubed minus 6x squared, and we have the line y equals to 0. All right, and they intersect when x is 0, when x is 6. So the first question is which function is on top? Well, obviously this one. So we want to set up our integral. It's from 0 to 6, and we're going to have 0 minus the bottom function, and you want to be really careful about that minus sign so you can distribute. So let's go ahead and distribute that, and that's the integral. Now we have to remember how to integrate. That's just going to be our power rule, so that's pretty easy. Just going to reduce here. So I have -6 to the 4th over 4 plus 2 times 6 cubed, and then I would subtract those functions evaluated at 0, which of course would be 0. Using my calculator, I get an area of 108 square units. So we now have another picture, much like that last example we talked about, so I can't just say the top function minus the bottom function because that changes at 0. So let's call this region 1 and this region 2. So for region 1, our area would go from x is negative 1 to 0, and we'd have the top function of 0 minus the lower function x times the square root of 1 minus x squared. Region 2 would go from 0 to 1, and this time we have our curve minus our line, and then we're going to add those regions together. I'm going to rewrite that square root as an exponent. So really we're integrating the same thing. There is a minus sign on that first integral, but let's see if we can remember how to do that. We're going to let u equal to 1 minus x squared, and then du would be negative 2x dx. So I have an x and a dx on both accounts, so I need to divide by negative 2. So I'm going to rewrite this integral, and again I'm going to integrate in terms of u and then go back and use these same limits of integration. Right, so if I substitute in, I'm going to take out that negative for this, and then x dx is du divided by negative 2. And then this is u to the 1/2 power. Continuing on, just in terms of u, again x dx is du over negative 2, and this is u to the 1/2 power. Right, so on this one I'm going to cancel out those negatives. U to the 1/2, I would add 1 and divide by that exponent, and then I have that 2 on the bottom there. On this one, I'm going to have the same thing, except that it's going to be negative. Now this is very misleading because you're thinking, oh, well, it's going to cancel out. Not quite yet. I probably should have used different variables here, but our limits of integration is going to be a little bit different, so we're going to cancel out those 2's. Right, so let's go back to what is u. U is 1 minus x squared, that's to the 3/2 power over 3, and that's integrated from negative 1 to 0. Then we're going to have minus 1 minus x squared to the 3/2 over 3, but that's integrated between 0 and 1. Let's see what happens. If I plug in 0 here, I'm going to have 1 minus 0, which is 1, so that's going to be 1/3. Minus, when I plug in negative 1, negative 1 squared is 1. 1 minus 1, that's going to be 0. Right? Now when I plug in 1 on this account, 1 squared is going to be 1. 1 minus 1 is 0. And then when I plug in 0, just like on the other one, I'm going to get 1/3. You're not going to get a negative answer because this negative with that negative makes positive, and we have an answer of 2/3. Now that's one way to work this problem. We could have also looked at this and looked at symmetry and said, you know what, region 1 is the same as region 2, so we could have, if we wanted to, we could have just taken that answer and multiplied by 2, or we could have taken this answer and multiplied by 2. Either way, we get the same answer. On this one, again, we've got some curves happening. This is not symmetrical, so I believe we're going to have to do this in 2 separate steps. So let's look at region 1. It goes from negative 1 to 0. We've got this upper curve here. Let's see, which one is that upper curve? That's that x squared minus this curve, which is x to the 1/3 power. Then region 2, this time this x to the 1/3 is going to be on top, and the parabola is on the bottom, and we're integrating from 0 to 1. So not the same area, we can't double it or anything like that, but let's go ahead and integrate this. pretty much doing the same integration. We're going to be using the power rule. Alright, so as we plug in our limits of 0, we're going to have 0 over 3 minus 0, so that's all 0. Minus, let's plug in a negative 1. Negative 1 cubed is negative 1. Alright, this is negative 1. The cube root of negative 1 is negative 1, but raised to the 4th power is positive 1. And then doing the other math, that's going to give us negative 3/4. Alright, same thing here. If I plug in 1, I'm going to get positive 3/4 minus 1/3, and when I plug in 0, I'm going to get 0. So that's all 0. This minus changes those both to positive. So 1/3 minus 1/3 cancels out. I've got 6/4, which is 3/2. On this next one, we're asked to sketch the graphs of f and g to find the area enclosed by these graphs. If you don't remember what the graphs look like, you might try a graphing calculator or a graphing thing on a computer, but hopefully these are basic graphs. This one's a line, this one's a parabola. You could get there from plotting points, and you should know that this parabola is going to point downward and so forth. But let's just go ahead and plot some points for f of x. So if I let x be 0, I'm going to get 0. And always let x be some positive numbers and some negative numbers. So when x is 1, we're going to have 2 minus 1 is 1. When x is 2, we're going to get 0. Negative 1, let's see, negative 2 minus 1 is negative 3. Then negative 4 minus 4 is negative 8. Let's see. Something like that. Then we have a horizontal line at y equals negative 3. The important thing to see is which one is above or below. So you don't need a very accurate graph, just so you'll know which way to subtract. And then of course we're bounded between negative 1 and positive 2. So we're looking at this region right there. So our area is going to be between negative 1 and 2. The upper graph is 2x minus x squared. The lower graph is negative 3. Be careful with that negative. So just using the power rule. Okay, be really careful with those negatives. When you square it, of course, it's positive, but when you cube it, you get a negative times that negative, and that's how I got that positive answer. Let's just go ahead. We could either use a calculator, fractions, whatever you feel most comfortable with. Again, I want to stress the fact that you got to be careful about that minus, and your final answer should be 9 square root units. Again, hopefully you remember that this is a parabola that shifted down 5 units, and this is a cubic function. All right, so let's see. When x is 0, y is going to be negative 5. I know that parabola goes up, and it looks something like this. Doesn't have to be perfect. Okay. What does that one look like? Again, you could plot some points. When x is 0, we get 0. When x is 1, we get a third. Let's see, what happens when x is 3? Wow, when x is 3, y is going to be way up here at 9. So you're going to get something that looks like that. Kind of scary. Between negative 1 and 2. Between negative 1 and positive 2. Well, which function is on top? It looks like this is on top, so that's the way we need to subtract. So we're going to go from 1/3 x cubed minus the parabola, and we're going to be bounded between negative 1 and 2. So let's distribute. And now integrate just using the power rule. And we just want to be really careful plugging in our numbers. And on this term, you want to just be careful about your order of operations. Negative 1 cubed times that negative, that's how I got the positive. And then using the magic of a calculator, I get an answer of 13.25 or 53/4. Okay, so this next one, Notice what is different. It doesn't tell us what it's bounded between. So we're going to have to find out because we want the region completely enclosed by these graphs. So our graph is probably going to be a little bit more accurate. So the first one, f of x is a line. Remember the slope is 1, b is 2. Okay, then we've got this parabola. Might want to plot some points, but we know it goes up. Okay, now remember that's not accurate, so what we need to know is we need to find this area, but more importantly, we've got to find the points of intersection. That's new. So how are we going to find the points of intersection? We want to know when is f of x equal to g of x. We're going to set those two functions equal to each other and solve for x. So we get to do a little bit of algebra. We're going to factor. So we get x is 3 and x is negative 2. Let's compare that to our graph. This point right there does look like negative 2. And when x is 3, 1, 2, 3, my graph was pretty good. Alright, so I want to set up my integral where I have f of x minus g of x, and my boundaries are between negative 2 and 3. So the new part is that you have to find where those two graphs intersect, and that's going to give your limits of integration. So we've got the problem from negative 2 to positive 3, f of x minus g of x, and that's what we need to integrate. So let's just use that power rule. Again, being very careful with your signs when you're plugging in a negative 2. Remember, you're going to just watch those exponents. The way I got a positive here is a negative cubed is negative, and then that negative makes it positive. And I got an answer of 20.83 repeating, or 125/6. So let's look at another problem, and notice this time I have a graph. On the homework, you have a choice of the graphs, and then you have to find the area. What I will do on the test is give you a graph much like you see here. It doesn't have a scale, so that means you still have to figure out the points of intersection and what they're bounded by. So let's look at f of x. F of x is a cubic function, and g of x is a line. So you should know that the red one is g of x, and the blue one is f of x. And so we want to find the area enclosed by these two things, these two functions. And so if you'll notice, we really have two regions. The first region we have where f of x is on top, and we're going to need to subtract g of x, and that would be region 1. And then we're going to have to add it to region 2, where g of x is on top and f of x is on the bottom. And so we need to find out our points of intersection, which would give our limits of integration. How do we do that? Just like on the previous example, we're going to set these two functions equal to each other and solve for x. Notice we have 3 points, which is good. So we've got 0, 2, and 4. Right, so on this first for region 1, we want to integrate between 0 and 2. And on the second region, we want to integrate between 2 and 4. So let's go ahead and set up those integrals. So from 0 to 2, we have f of x minus g of x. And then for the region 2, we're going to integrate between 2 and 4, and we have g of x minus f of x. So we want to be careful and distribute those minus signs. And I'm going to combine those two terms and have a negative 8x. As you look at these two functions, they're exactly the opposite, so that means those regions, region 1 and region 2, are exactly the same. And so we could have just taken one of these regions and doubled it, but I wasn't sure of that, and they're not necessarily always the same, so I think this is the safe way to go. Right, so we're just going to use the power rule. So let's integrate. Right, now if I plug in 0 to all of those, that's just going to be 0. So let's just do all of that arithmetic. And I believe after all is said and done, the answer should be 8. Let's look at this next graph. We are given f of x, which is this strange looking thing, and g of x, so I know that's a line, and so this has got to be f of x. So the region that's enclosed by those two functions is just this little bitty part right there. So we need to find 2 points of intersection. So again, I'm going to set those two functions equal to each other. I think I'm going to go ahead and multiply both sides by 2 to get rid of the fractions. Now I need to get rid of the square root, so I'm going to square both sides. So I've got to square that, that's 4x squared, and when I square the square root, it just goes away. So I'm going to distribute that, subtract, so I get 2 points of intersection. The 0 looks very reasonable, and that should be a negative 7/4. And so I want to integrate, and notice this time the g of x is on top, so I want to take g of x and I want to subtract f of x, and I want to integrate between negative 7/4 and 0. All right, so let's look at that integral. Let's change that to an exponent. So let's look and see how we integrate that. I know how to integrate this. We're just going to use the power rule. It is this function that looks somewhat difficult to me. So I have something raised to a power. I'm thinking I might need u substitution. So if I let u equal to x plus 2, then du is dx. But I've got this x out here. That looks kind of scary. So let me take this, and what if I solve for x? So u plus 2 is equal to x. If I have x times the square root of x plus 2, and I use u substitution, well, that would be my u, so I would have u to the half, right? But then I've got x dx. Well, dx is du, so I'm okay there. But what is x? X is u plus 2. Now that just looks like I'm going around in circles. Well, now I can distribute, and I've got u to the 3/2, multiplying that, plus 2u to the half. I can at least use the power rule there. And so that would integrate as u to the 5/2 times 2/5 plus 2 times u to the 3/2 times 2/3 plus c. I'm going to come back up here and remember integrating that. So let's see. Starting back up here, I have 1/2 times x squared over 2. Then I've got this integral here, and I need to subtract it, so I'm going to say minus, and I have this result, but I need to replace my u's with what was u equal to, which was in terms of x. So that's minus 2/5 times u, which is x plus 2 to the 5/2. And then this is going to be 4/3, 2 times 2 over 3, times u to the 3/2. And all that is integrated between negative 7/4 and 0. So I've got x squared over 4. Okay, so let's see what's going to happen when I plug in 0. I'm going to have 0 minus 2/5 times 2 to the 5/2 plus 4/3 times 2 to the 3/2 minus, right, I've got this fourth on the bottom, so if I square negative 7/4, then minus 2/5, negative 7/4 plus 2 is 1/4, and then I'm going to have 1/4 again. And now please go to the calculator and get a decimal answer. I know this is some really what I would call yucky numbers, but thank goodness for calculators. The reason why I did this problem is because the last one on your homework has that same type of integral. And this is the weird integral and what you need to do. It's not that hard, it's just different. So good luck.